was Pluto. So Clyde discovered Pluto, and I met Clyde in about 1975. He was a wonderful gentleman and still honored for his discovery of the planet Pluto. Now we'll get to some better ones. So before we went there, these were the best images of Pluto. This image here shows Pluto and its moon Charon. And then we put the Hubble telescope in, we got a better view. But you can see all they are dots. And Charon is the name of Pluto's moon. And this is the best view of Pluto we had before the recent mission. This is a picture of another planet taken with shown to you with the same resolution that we understood Pluto. Anybody know which planet is the blue planet? It's Earth. Yeah, this is how Earth would look if the people of Pluto, were there any people on Pluto, had a Hubble Space Telescope to look at the Earth. So you can see there's a lot more to the Earth than what we might know by looking at Pluto scale. So here is our best modern view of Pluto. So Pluto has an orbit. Now, 1 AU, 1 astronomical unit, is the size of the Earth's orbit. So Pluto's orbit, the closest it gets to the Sun is 30 times further than the Earth. And the farthest is 50 times further than the Earth. And it takes 248 Earth years to go around the Sun. And this means that spring on Pluto lasts 60 years, and winter lasts 60 years, and summer lasts 60 years. So it's really a long time to go around. Long winter. Winter is coming. And in fact, winter is coming to Pluto. And that's why we went there now. Because it's going to get so cold on Pluto that the entire atmosphere is going to condense onto the surface as snow. And the atmosphere is going to go away. Soon, we'd have to wait almost 180 years. So it takes Pluto about 6.387 days to rotate once. 6 Earth days to rotate once. And if you look up in the sky above us, I made a scale model of Pluto and Charon, its moon, that are orbiting. And you can see them. Pluto is the bright one, the big one, and Charon is dark. And this is exactly to scale. And if you look, you might see that there's a faint dot outside of Pluto on its way to Charon. And so it turns out, as Pluto goes around, it keeps one face towards Charon all the time, and Charon keeps one face towards Pluto. So on the Earth, yeah, that's right. I love that comment, Shauna. Yeah, the sky is falling when the air falls out of Pluto. So get this. So Pluto rotates once in 6.4 days. It orbits once in 6.4 days around the center of mass. And Charon, the moon, orbits once in 6.4 days and rotates once in 6.4 days. So the moon of Pluto keeps its same face towards Pluto just like our moon does. But Pluto points its same face towards the moon. So the moon in Pluto's sky remains in the sky in the same place at all times. It never rises, it never sets, it just hangs there. So one reason to study other worlds is to open the eyes of middle school students to, hey, you know, you're used to the moon rising and setting. It doesn't have to be that way. And in fact, in a few billion years, our moon will take 1 month take 40 days to go around the Earth. It's going to slow down its orbit as it moves away. And the Earth's rotation will slow down so that the Earth will rotate once in 40 days. And the very same thing that's happened to Pluto now will happen to the Earth and its moon. The moon will seem to stop in the sky and hang over one place on the Earth. And that's amazing. You can ask questions in comments, and I'll do in chat. If you can ask questions in chat, and I will try to respond. I do lots of lectures in Second Life. I try my best. The temperature on Pluto is brutally cold. So it turns out, and this scale, the Kelvin scale, that's what K means. So 33 Kelvin is like minus 500 Fahrenheit. This is really cold. Or for those of you in Celsius, it's like minus 240 Celsius. So that's really cold. We'll get to more effects later. And the gravity is 1/16 of Earth gravity. So you'd fall very slowly on Pluto. Just this very slow fall. I should make an exhibit that lets you see what the fall is like. That's right, slow falling snow. If you've ever dealt with liquid nitrogen is twice as warm as the temperature on Pluto. In fact, at Pluto temperatures, nitrogen is solid. So here are the sizes, and you can see here Earth and our moon and Pluto to scale. And Pluto is about 2/10 the diameter of the Earth, and it's about 2,000ths the mass of the Earth. So it's like almost 1,000 times less massive than the Earth. So you can see why some astronomers might want to kick it out of the family of planets. It's smaller than our moon, but it's out there on its own, so it's okay to be a planet, I think. So, here's one of the reasons that they made Pluto not a planet. So, we discovered Pluto was the first of these worlds beyond Neptune to be discovered. And Pluto has its moon, Charon. But in addition to Pluto, we've discovered other objects out beyond Neptune. Eris, Makemake, Haumea, Sedna, Quasar. In the asteroid belt, there's Ceres and Pallas and Vesta, and some that don't even have names yet. And so they worried that KOR, for example, it's got a name, and Orcus. So they began to worry that if they counted Pluto as a planet, all of a sudden, all the planets we'd come to know and love would be outnumbered by these distant icy worlds. So they wanted to come up with a new way to separate out these new distant icy worlds. So they called them dwarf planets and demoted Pluto. I still think Pluto's a planet. In fact, here is a picture that shows you all of the new icy bodies discovered beyond the orbit of Neptune. So the outermost circle here is the orbit of Neptune, and here's Uranus and Saturn and Jupiter, and the Earth is way in here near the sun. And look at all these thousands of objects we're discovering far out here beyond Neptune. They're called trans-Neptunian objects. So they really worried that all of a sudden, if we didn't redefine Pluto, the solar system would become a solar system full of ice. So they changed it. Well, to get out there and study these things, the big white dots are the dwarf planets. They're not to scale. Those big white dots are relative to each other, but they're much smaller than Neptune. And Pluto is still the biggest of all of those white dots. Okay, so Sorry about that. Yeah, that was not a great slide. So here is the spacecraft we sent. Took 10 years to get from the Earth to Pluto, and it was the fastest thing we ever sent out there. So some of the things I'll be showing you is that we have Lori, the high-resolution imager. That's going to take the great pictures. And we also had Alice. And when Alice takes a picture, it tells you what something is made of. You notice these are sort of named after the honeymooners. And Ralph also tells you what something is made of. And we look at particles and dust and magnetic fields. And here's the really cool thing. Yeah, dust. Yeah, there's lots of dust out there. The solar system is a dusty place. The spacecraft is powered by radioactive decay. The spacecraft is powered by radioactive decay of plutonium. And plutonium is a man-made element that's named after Pluto. So I think that's really cool that the spacecraft that we sent to study Pluto is powered by the radioactive decay of a man-made element, plutonium-238. And here's the size of the spacecraft compared to people. And this thing here with the black fins on it is the plutonium power source. Inside of that, there's plutonium that stays incandescently hot by radioactive decay all the time and can be used as the power supply for this spacecraft. The plutonium is radioactively decaying. There are many kinds of plutonium. The kind they use in bombs lasts thousands of years. The kind they use to power a spacecraft that's plutonium-239. Plutonium-238 decays in decades. So in tens of years, this will begin to run out of power. When we look with those spectrometers, this tells us what Pluto's surface is made of. It's made of methane, that's natural gas, carbon monoxide, the atmosphere is poisonous, and nitrogen. You couldn't live on Pluto except with a spacesuit to provide you oxygen. And besides, it's super cold, you better have a heater. And this is the spectrum. We look in the infrared, and by looking in the infrared, it tells us these little dips that you see here in the spectrum. This dip is due to methane, and this dip is due to nitrogen, and this is carbon monoxide over here. So you can look at something with the tools of science and tell what it's made of. No traces of oxygen. Just none. Pluto and Charon, as I said, they both rotate in 6.4 days, and they both orbit in 6.4 days. So they and the Pluto actually goes around in a circle. The Earth goes around in a circle because of the moon pulling on us, but the center of our circle is inside of the Earth. Pluto is the only planet that the center of the circle that it goes around in is outside the planet. So it has a big moon compared to the planet. Okay, so here's a picture of Pluto that shows what I expected. And up here on the right, you see a distant photo, and it shows you where this picture is taken. And look at this. We looked at Pluto, and we see this beautiful white heart-shaped region. Pluto had this wonderful white heart in it. And the name of this, the lobe of this heart, is called Sputnik Planum, the plane of Sputnik. And off on the edge of the plane of Sputnik is this. It's what we thought we'd see. Crater after crater after crater after crater. But there were some surprises in this picture. The white stuff here is snow. but it's methane snow. If you have natural gas in your house powering your hot water heater or your stove, that's powered by methane. It's a gas on Earth. But at the temperatures of Pluto, it's snow, and it's white, and it falls on the mountains of Pluto. And then, in the bottom of this crater was a flat, white thing. We think that's a frozen lake. But by looking at it, we know that it's a lake filled with frozen nitrogen. So it's a solid nitrogen lake. And maybe at some time in the past, that was a liquid nitrogen ocean, or a liquid nitrogen pond, that as Pluto winter came, it solidified and has remained solid for a billion years. So that's what we expected. But what we got was surprising. So here's a picture of Sputnik Planum. It's this big, flat plain. Flat, we didn't expect. There's not a single crater on it. And that's completely unusual in the solar system. And when we look at it, it's made of solid nitrogen. This white surface is a gigantic frozen ocean of liquid nitrogen that's now solid. Yeah, so there may be a liquid ocean, maybe even liquid water, underneath this. And we'll come back and talk about that, because that's a discovery that's only made in the last few days. Over here, these craters we'll see close-ups later. These are craters, and the white rings around them, ring around the crater, are as methane snow. But when scientists saw this big white uncratered plain, we were all blown away. Never expected it. So, let's take a look at this picture. Look at how the mountains over here stick up above the edge of Pluto. They're high mountains. And these are mountains here. So, these mountains are made of a very hard substance, water ice. It turns out at Pluto temperatures, water ice is harder than granite on Earth. So these mountains can withstand the weak gravity of Pluto because they're so strong. And over here, there's nitrogen ice, a solid nitrogen ice ocean. And it turns out at these temperatures, nitrogen ice behaves like silly putty. Do you remember silly putty? It slowly flows like a slow lava lamp. It's solid. You could walk on it, but over time it slowly moves like a glacier on Earth. We were shocked, and to this moment we have no idea what has provided the power source to keep Pluto warm enough to make the nitrogen flow. There's lots we don't know about Pluto. So as we look at Pluto, over here, this is where we're looking. Here's Sputnik Planum. This is to the lower left. In visible light, these are mountains, and all the white on the crest of these mountains is methane snow. And this is viewed in the infrared. And the infrared, the methane snows up as purple. Oh, good Prince. Purple rain. Purple snow. We need a new song. Prince is dead. But it shows up in the infrared. We chose to portray it as purple. But the infrared identifies it as exactly methane snow. So when I tell you that the white stuff is methane, it's because we've looked with our spectrometers in the infrared and found out it really was methane. Now, here we've changed the exposure on Sputnik Planum to bring out the detail. And what you're seeing here is the convection currents. That this is the solid nitrogen ocean on Pluto. and something is warming it underneath, which is causing it to convect like boiling water in a pot on Earth. And it rises up in the center and flows to the edge and sinks again and goes back down. This was totally unexpected. That's just an amazing image. Here it is in close-up. So this is near the edge of the methane ocean. These are water ice mountains, and this is a methane ice ocean, and it's rising in the middle of each one of these polygons, and it's descending on the black lines in between. So these are conveyor belts. They come up in the middle, they flow to the edge, they go down. They come back to the middle, they flow to the edge, they go down. Absolutely amazing. Here we are looking at Sputnik Planum, and the kind of things we see. And what I want to point out to you in this picture is glaciers. So the methane, not glaciers made of ice, glaciers made of methane. And we'll get some close-ups in a minute, and you'll be able to see that there's flow happening. So let's get some close-ups. Oh, actually, so this is rather interesting. These things here are icebergs. These are water icebergs, and they're floating in the sea of solid nitrogen. And the icebergs have gathered along one of the descending ridges. But water ice is less dense than nitrogen ice. So water ice floats in the nitrogen ocean, but the icebergs get collected along the ribs. Here's another iceberg, and it's collected along this rib here. So it's really interesting to see mountains made of water ice that are moving on the surface of Pluto because the surface is solid nitrogen that moves. And here we have some of the glacier flow. So if you look in this picture right up here, you'll see something that's flowing and spreading. So I'll move away. And right here, there's another flow that's moving this way. So it's a little hard to see, but if you look, you can begin to see that it looks like the nitrogen has flowed towards the land. And here, the nitrogen has flowed this way. So there are glaciers on Pluto made of nitrogen. In fact, here's some more. I'm going to show you one here. Nitrogen ice flow in the pictures. It's flowing this way, and it starts here and it flows that way, and it starts here and it flows that way. So the nitrogen ice is in motion, we believe. Here's a false color image. And in this image right here, we think that there's glacial flow along this line. And in the lower picture here, you can see it in black and white. You can see the streaks that indicate that there's flow going on. This is how a glacier looks on Earth when it has rocks in the ice, the water ice on Earth glaciers. The rocks get stretched out into lines. We think the water ice rocks that have fallen onto the glacier of nitrogen ice get carried along and leave streaks on the Pluto glaciers. And the glaciers flow, and here they're flowing out from the land, and these are the flow fronts. These are where the glaciers stop flowing. So there's a giant lobe of ice flow flowing out onto Sputnik Planum. Pluto's this interesting place. Okay, a few other things. As you look down at this image, that's a really hard image to interpret. Each one of these dots is actually a pit. And it's a pit that might be 5 miles across. So think about something that's 5 miles away from you. and 1.5 miles deep. It's deeper than the Grand Canyon. And there are thousands of these pits, and we don't know what makes them. Now on Earth, we find things like this. When I go hiking in the mountains, I might find, this is Earth, a patch, and there'll be little dimples or depressions in the surface, and those are called sun cups. And when the sun shines on naked ice, it can be focused by the ice and make so a smooth, flat surface of ice turns into a pit. And so some scientists think that these pits on Pluto are made by the sun, but other scientists say, no, we just don't know what made those pits. Maybe there's some volcanism underneath that melted the ice. We have lots to learn on Pluto. And here's a geologic map. The colors here mean different surface materials. Yellow is kind of water ice, and the white is nitrogen, and every one of these black lines here is one of those places where the convecting nitrogen goes down. Yeah, dark green. I don't know what dark green or light green are. There is a key that goes with this that identifies every color. So some of the other colors, and I'm not sure, I don't remember which ones are which. Some of those colors are carbon monoxide snow, nitrogen ice, methane ice, water ice. So those are some of the chemicals. And the red ones is something called tholins. And I'll type the name here for you because it's a funny word. Tholins. And a tholin is like tar. It's a hydrocarbon like we pave our roads with. And the sun takes the carbon dioxide that's on Pluto, and the ultraviolet from the sun breaks off the carbon, and it breaks off the hydrogen from methane, and they come together to make hydrocarbons, which make asphalt. And in fact, this dark region here, on the dark reddish region on Pluto, is just covered with this rain of tiny asphalt particles called tholins. Another picture of the other lobe. This is the other lobe on Sputnik Planum. And the scientists saw something over here on the corner. This stuff over here, like we had never seen on any planet before. And I will now show you a close-up of that terrain. Here's a close-up. They called it snakeskin terrain, and it's full of tiny ridges. And they have these giant canyons here that may have been carved by liquid nitrogen rivers. But but what makes this ripply structure? Graduate students at this moment are working on a thesis to try to figure out what causes that texture. We don't know. Isn't it great when scientists get puzzled and they don't know the answer? Yeah, someone paving, right? So Pluto's North Pole is up here, and you can see the yellows from some thin tholins. Let me give you a little close-up of Pluto's North Pole. There's the North Pole in the picture. And around the North Pole, there are canyons, shown in green here. This green canyon and this blue canyon. And one of the reasons that a planet like Pluto can get parallel canyons like this is if the planet swells up. So the crust is solid. But if something inside the planet, think alien, swells up and gets bigger, the surface has to crack to allow room for that new expansion. Well, stretch marks, exactly stretch marks. And one way this can happen, and this was just proposed last week, is that inside of Pluto, there could be, or have been, a liquid water ocean. And when water freezes, it expands. Ice floats on water. So one thing is, Pluto could have an ocean underneath the crust that is slowly freezing, expanding, and cracking the crust. We know that places like Enceladus, a moon of Saturn, has a liquid ocean underneath the ice surface. And that some of the moons of Jupiter, Europa, Callisto, might have oceans as well. Here's an interesting place. Here's a mountain on Pluto, and it's got a big crater in the middle and a raised edge, and it really looks like stuff flowed away from it. And you can see the size down here, 35 miles or 50 kilometers. Scientists think this might be a volcano on Pluto. But on Pluto, a molten rock is something we call water on Earth. The magma, or molten rock on Pluto, the rock on Pluto is made of water ice. The magma is liquid water. So this may be a Pluto volcano that spewed out liquid water that then froze solid once it got out. So there must be some heat source in Pluto to make that water come out. Well, one thing we did was we got to fly behind Pluto. So the sun is on the other side of Pluto when we took this picture. And it shows us Pluto's atmosphere. And Pluto has this beautiful blue atmosphere, no oxygen. But these pictures of the atmosphere let us understand Pluto's atmosphere. And one of the reasons we went to Pluto now is that Pluto is moving into winter. Winter is coming, and it's going to be winter for 60 years. And when winter comes, it gets so cold on Pluto in the winter that the atmosphere will fall out of the atmosphere as snow and go onto the surface, and there'll be no atmosphere left. This happens somewhat on Mars even. In the winter on Mars, a good fraction of the atmosphere snows out at the winter pole. So we really wanted to get to Pluto while it still had an atmosphere, and we made it just in time. And one of the great things about these low-angle pictures, so the sun is up here on the top, shining down towards the bottom, and in this picture, every little mountain peak is casting a shadow. So these black lines here are all shadows of mountain peaks, and they're shadows onto the air. The air is full of haze or mist, and so the low haze shows you the shadows of the mountains, and I really like that. Well, here's something else about Pluto. On the Earth's axis is tilted 23 degrees. You were taught that in school. And in fact, the Arctic Circle reaches 23 degrees from the pole. And 23 degrees from the pole, in the winter, the sun never rises. And in the summer, the sun never sets. Well, on Pluto, it's tipped 120 degrees. It's tipped right over on its side. And that means that the Arctic Circle stretches from the pole all the way down to within 30 degrees of the, 60 degrees, 30 degrees of the equator. So a huge fraction of Pluto is in the Arctic. And that's really different from the Earth. So not only is Pluto basically cold, some parts of Pluto, the sun doesn't, at the South Pole on Pluto, the sun won't rise for 60 years. You don't want to be on Pluto if you don't like cold. The other thing is, on the Earth, there's something called the tropics. And the tropics on Earth go 23.5 degrees north of the equator, and the Tropic of Cancer, and 23.5 degrees south of the equator, the Tropic of Capricorn. And if you're in the tropics, the sun at some time of year is straight overhead. That's what defines the tropics. The sun at noon is straight overhead. That's not true if you're not in the tropics. On Pluto, the tropics go to 60 degrees north and 60 degrees south. Pluto's Arctic goes to 30 degrees north and 30 degrees south. This means, and this is mind-boggling, in Pluto, the tropics is further north than the Arctic Circle. So Pluto has a place, unlike the Earth, which is called the tropical Arctic. And here's an amazing thing when we look at Pluto. The part of Pluto that is the tropics, that is not the tropical Arctic, is dark. It's always dark. Whereas the part that's tropical Arctic or Arctic is light. For some reason, the tholins, these dark chemicals, gather only in the tropics. So even though it's really cold in the tropics on Pluto, it's warm enough to make the chemistry different. So, if you're teaching middle school kids and they think, oh, I understand the tropics, I understand the Arctic, you say, okay, kid, here's a planet tipped over 120 degrees. You can even just tip it 60 degrees. Tell me about the Arctic and the tropics on that planet. Let me tell you, even the high school teachers that I teach have their minds blown when they have to figure this out. Okay, so here's another liquid nitrogen lake on Pluto. This is a lake. It's now solid. It's made of nitrogen. Here's some canyons, some rivers on Pluto with braided streams, just like you'd find on Earth. And we think that these river channels were carved by flowing liquid nitrogen. The water can't flow ever on Pluto at the surface. Underground, where it's warm, water could be liquid, but not on the surface, we don't think. And here, this terrain here, look at the fractures here on the surface. We see these on one place on Mars, and we just don't know what made them. Maybe they're nitrogen rivers that carved the surface. A big puzzle. What made these? The only other place we see of them is Mars, and we don't know what made them on Mars. And here's that dark band I was telling you about. It's really dark. The bottom here, when we flew by Pluto, we flew over the only one pole, and we have no images of this dark region under here. We have to wait another 20 years before we send another spacecraft to Pluto to photograph this other half. What's hiding down there? Well, here's Pluto's moon, Charon, and it's got reddish tholins on the pole. It's got a giant canyon that wraps around the equator, much deeper than the Grand Canyon on Earth. Look at this canyon up here. And we think the same thing happened on Charon as on Pluto. We think this one is really made of water ice. That it was, when it first formed, it was liquid, but the water ice has frozen, the water liquid has frozen and expanded, and the expansion has cracked the surface of this moon of Pluto. And here are the other moons of Pluto. So on the bottom is Charon for scale. It's the big one. But we've got other moons, and the other moons are Styx, and that's the best picture we have of Styx. Nix, you can actually see a crater over here on Nix. Kerberos, really tiny, and Hydra. And Hydra has a couple craters on it as well. And it's looking like these are made of water ice. So in fact, down here you see the scale. This bar is 10 miles or 10 kilometers, and it applies for all of these moons. So Hydra is like 15 miles across, and Kerberos is just a few miles across, and Nix is maybe 20 miles, 30 miles from end to end. And so, yeah, these are small. Sorry about that. I didn't want to do that one. So if you want to read some more about this, in the July-August issue of the Magazine of Fantasy and Science Fiction, I have Isaac Asimov's old jobs. And Isaac Asimov's, one of his jobs was to write the science fact column for the Magazine of Fantasy and Science Fiction. And so in the July-August issue, which you'll be able to find online in a couple months, there's an article which describes all the things I just told you. It's called The Ice Worlds of the Solar System by me, that's my real name, and by Pat Murphy, who's a phenomenally good science fiction writer who I work with all the time. And in fact, so these moons of Pluto are the size of asteroids, except that if they ever came near the sun, they would sublime and blast out dust and a tail and become comets. So these small moons of Pluto are much more like comets than they are asteroids. And so now, that was usually the last slide, but in the last week, we have some new images. They took all these images on a few days in July of 2015. And they've been sending the data back ever since. And it's going to take a year and a half to get all the data back. So these are the latest images from Pluto. So I think I showed you some, a not close-up before. These are craters. They're called halo craters. They're all surrounded by rings of nitrogen, of methane snow. And plus, here are some of the cracks here in the middle due to the, we think, expansion of Pluto by the freezing of water. And here is a new image, and you can see the pits, these pits that are deeper than the Grand Canyon and a few miles across. And then we come over here from the nitrogen ice to the water ice. This is to the bottom right of Sputnik Planum, and this is water ice covered by tholins, by the asphalt. And that's a new image. And then the last image of my talk and the last image of Pluto, in the most recent image we sent back, we saw the very first cloud. This white spot here, we believe, is a cloud on Pluto. And we now have to look at it with look at the data sent back about what is that cloud made of? What is it? Methane cloud? Is it carbon monoxide? What is it? What kind of cloud is it? This whiteness over here we actually think is snow on mountains. But this whiteness we think is a cloud. In all the pictures we've taken, we've only seen one cloud. And actually, if you look at the atmosphere here, you can see haze layers. These layers are real. They're not computer processing. So the atmosphere of Pluto has all of these wonderful layers in it that we're trying to understand. And that atmosphere will go away in the next few years. It'll just all fall out as snow. Anyway, so that's my lecture on Pluto. I hope you enjoyed it, and I'll take any questions you had. No plans for a lander right now. However, we are going to land on the moons of Pluto, of Jupiter. So we are planning on sending an exploratory lander to land on one of the moons of Jupiter. And we will plan in the future to go back to Enceladus. It's a moon of Saturn that has a water liquid ocean. And worlds with water liquid oceans are the best place to look for life in the solar system. And we would dearly love to find some other life forms out there in space. But Pluto is so far away. If once we launch, it's 10 years to get there, and it's going to take at least 10 years to design and build a new mission. So the next trip to Pluto is at least 20 years away. And I hope you get the idea. The images, oops, what happened? Did I freeze? Uh-oh. I think something bad happened. Oh, there we go. I'm back. Yeah, so I hope you realize the experts, the world's experts on other worlds, looked at the images coming back from Pluto and were completely confused. That's the story we need to teach our students. When you actually go and do science and you look, you will discover things you never expected. Science is not about knowing everything. It's about looking for new things. Yeah, there was a little freeze there. I don't know what happened. I'm sorry. I'm still here. Oh, yeah. Core of Pluto. So it turns out one of the things you can find out by having a spacecraft fly past a planet is you can measure the mass of the planet. So we now know the mass of Pluto very well. And we can also measure the size of Pluto so we can get the density of Pluto. And if Pluto had a density of 1, that would mean it had the density of water ice, and it would be all water ice. But Pluto has more like a density of 2, a little bit over 2. And that means it's like a 50-50 mixture of water ice and rock. Earth-type rock, I mean like silicate rock. But we don't know, the surface all looks like ice. So that means that probably inside the center of Pluto, there is a core of rock. Now, Charon and the other moons that we can, as we went by, seem to have a density much closer to 1. So we think the moons are much more pure ice, whereas Pluto is a mixture of ice and rock. Yeah, so there is something, well, it turns out, of course, on Pluto, at the temperatures of Pluto, water ice is harder than granite is on Earth. So, yeah, but there's something other than water ice. There is rock somewhere down there. And it's interesting. You notice I did what a scientist would do. I not only gave you the answer, I told you why we think that's the answer. I told you how we measured the mass and how we measured the size. And whenever you have a real scientist talking to you, you can always ask them, what's your evidence? How do you know that? And they have to be able to tell you the experiment that they used. No, so we did not see any ozone in the atmosphere of Pluto. It was carbon monoxide, methane, mostly nitrogen. There's just not much. Oxygen is tremendously reactive with tholins. When you have hydrocarbons around, if oxygen comes, it reacts immediately, so the oxygen gets removed. Yeah, so the strength of rock, so granite, when it gets really cold, does get a little bit harder, and it gets much more brittle. It shatters better, so it's harder, but it breaks easier. That's kind of a funny mix. Here's an interesting story. So I have been to Antarctica, and in Antarctica, I visited a place called the Dry Valleys. And the dry valleys have cliffs made of granite. And the cliffs of granite have caves carved in them. And the caves in the dry valleys of Antarctica were carved by blowing snow, because on Earth, at the temperatures they reach in the Antarctic, minus 60 Celsius, water, ice, snow is as hard as feldspar, which is a part of granite. So snow can eat away granite on Earth. And on Pluto, it's much colder still. So on Pluto, water ice is even harder than all the components of granite. So really interesting. Yeah, so really cold. If you had snow at really cold temperatures, you could use it to sand wood. It would be sandpaper, as long as the wood was cold. Yeah, so until a few years ago, Pluto was closer to the sun than Neptune was. In its orbit, you notice Pluto sometimes is 30 times further than the Earth from the sun, and sometimes 50 times further than the Earth from the sun. Well, Neptune is more in a circular orbit, and it's like, 34 times further than the Earth from the sun. So sometimes Pluto is closer to the sun than Neptune. And one hypothesis for Pluto is that Pluto started out as a moon of Neptune. And some big collision, some other moon of Neptune came close, and Pluto got thrown out away from Neptune into its own orbit around the sun. And now the thing is, Pluto its orbit is tipped a little bit to the side. So even though it crosses the orbit of Neptune twice every 248 years, it always manages to be above the position where Neptune would be at that time. So we don't really know where Pluto was made, but it does cross the orbit of Neptune. Well, it crosses the distance of Neptune, but it's above. It never actually is on a collision course with Neptune. That would be, actually, it'd be really spectacular to see. If Pluto came in and hit Neptune, it would give Neptune a ring bigger than Saturn. So you'd have this beautiful ring of Neptune as the material from Pluto and Neptune got spread around Neptune in orbit. Right. So they never. So Neptune can really perturb Pluto's orbit. You have to realize the chance only happens every couple hundred years, but Pluto gets close enough that Neptune can change its orbit every time it comes around a little bit. And over millions and millions of years, this could add up to perturb Pluto's orbit a lot. Capturing is really hard. It's very, very difficult for a planet to capture a moon. It's much easier to lose one than it is to capture one, because it's like as it falls in, it gets faster, and the speed can carry it away on the other side, unless it interacts with another moon. Any other things you ever wondered about planets? Any of the planets or Pluto? So yeah, it's called It's called, oops, Kuiper. Oops, I misspelled. Kuiper. There we go. It's Kuiper's Belt, and it's close to it. In fact, so just outside of Neptune, there are many icy worlds like Pluto, and it's called the Kuiper Belt. Just like there's the asteroid belt full of rocks that go around between Mars and Jupiter. Well, outside of Neptune, there's the Kuiper Belt full of icy bodies like Pluto. And Pluto could be part of it. But then way out beyond the Kuiper Belt, there's something called the Oort cloud. And it also has icy bodies in it. And that goes a long way out, far, far out, towards other stars. So, and that's the end of the solar system, as far as we know. There's the planets, and then the Kuiper Belt of icy bodies, and then the Oort cloud of even icier bodies out further, and that's as far as we know. Well, it's been a pleasure to be here with you, and I hope that I hit it at about the right level where you could understand my interpretation of the images. I tried to get the best images, and you had great questions, great audience, and I want to leave in a little bit so I can go catch my train home. I'm doing this from my desk at work.
Thank you.
Yay! So I look forward to next year. I'll have a different lecture. Oh, wow.